All right, good morning, class. Sorry, today the professor is not here. However, the two GSIs of IOE 265 will teach you today. My name is Vedant.
My name is Sahab.
All right, so let's get started. So first off, we here have a systems probability problem. And before we even get started on this problem, there's one important assumption that needs to be made. Do any of you guys know what that assumption is?
Anybody?
No
Anybody?
volunteers? All right,
No
so
volunteers?
start calling some names
Start
out.
calling some names out. Obviously, this is what always happens. Okay. First name is Aaron. Aaron. Aaron Balake. No Aaron. No Aaron. Okay. D Nice. Do we have a D Nice here? Okay. A Denard Robinson. Denard Robinson.
Sounds familiar.
You go office hours?
Maybe.
I don't know what's going on. Maybe clean office hours, I think. Okay, so obviously no one's here in class. I know you like to skip your classes as morning classes. I know certain people like to skip morning classes. Me. So we're just gonna move on. I'm just gonna give you the answer. The thing you have to assume is that each of these elements in the problem are independent. Okay? So I'm gonna give you an example of that to make it like a little easier for you to understand. So independent, right? So you got element A, you got element B, right? My handwriting's not the best, but you can read it. You got element A, element B. One assumption, one equation that you need to know, because it's gonna be on the exam. And you don't want to forget it because you're gonna have to end up doing some extra credit after. Okay? So this problem, how you do it, so the one thing, the equation to memorize here is A union, okay? Remember A union, you have to remember the U. B is equal to A plus B minus A intersection B. Okay, remember that. Remember that. And the one thing we'll also memorize is A intersection is equal to A times B, the probability of these successes. So in this problem, what we're given is like a sewage system, okay? That's what I like to think about it. You can go through 3 different paths. You can go through 1, you can go through 2, or you can go to 3 and 4. Both these, if they're like gates, right? 3 and 4 both have to be open. You can't have one closed and have it work. Okay? And the probability of each of these being open or successful is 0.9. Okay? Vedant's going to take it on from here. Just remember this equation is going to be on the exam.
All right, thank you, Sahab. So what we have, as Sahab mentioned, is that we have like 3 different ways that it can work, right? You can go through just 1, or just 2, or 3 and 4, okay? So we'll just label this as A. We'll label this as B, we'll label this as C, and we'll label this as D, okay? So what we have now is for the whole system to work, so we can just say the probability of the entire system to work, which is what we're trying to solve, is just equal to the probability of A, or, so just A working, or, which we'll keep as the union, the probability of B, this whole thing, or the probability of C and probability of D. Because of that and, we're going to have this intersection instead of a union. So, another way to make this easier to look at is that we can just call this whole section X, and we'll call this whole section Y. So now we can rewrite this entire problem as just probability of system is just equal to probability of X plus probability of Y. Let me just get this out of the way real quick. Probability of Y minus the probability of the intersection, probability of X times Y, which we defined earlier, as Sam mentioned earlier. So now let's just define what probability of X is. Okay, so we have probability of X is as P of A union P of B. So that's just also probability of A plus probability of B minus the probability of A times probability of B. And we know the probability of A is just 0.9. The probability of is just 0.9 minus 0.9 times 0.9. So we can also just set, so then we can have this equal to 1.8 minus 0.81 is equal to 0.99. Okay, so I'll just write it over here. The probability of x is equal to 0.99. Okay? Let's get this out of the way. Next, we want to just define what probability of y is. Well, probability of y is just the probability of C intersection with D. So all that is just 0.9 times 0.9, which equals 0.81. Alright, so we'll write that over here. Probability of y is equal to 0.81. Let's get this out of the way as well. Now that we have the probability of both x and y, now we can just solve for the probability of the system. So this just equals P of x, we have 0.99 plus probability of y, which is 0.81 minus the probability of 0.99 times 0.81. And after doing some calculations with your calculator, you're going to get the final probability to be 0.9981. And that is your final answer. So all problems similar to this, can be solved just like this.